This how-to video is Acid Bases and Buffers Worksheet 1 question 2, specifically section B, C and D. And what I've done is I've pasted onto the page the relevant details of the question and some additional information that we're going to need to answer the questions. So section D is quite simply write an expression for Ka of benzoic acid, and this is an expression that you'll be required to remember for this part of the syllabus. So here we go. So this is the actual expression for the acid dissociation constant, and what I've done is I've rearranged it like I have done in other videos to make the hydrogen ion concentration the subject of the expression, and we're going to need this for section C, which we move on to now. So section C, what we need to do is to work out the concentration in moles per decimeter cubed of the benzoic acid and the sodium benzoate, and we do that like this. So general expression, number of moles equals mass over molar mass. We've got 4.88 grams of benzoic acid divided by its molar mass, which is 122, which gives us 0.04 moles, and the volume of the solution we're talking about here is 500 centimeters cubed. So to express this in moles per decimeter cubed, we multiply the 0.04 moles by 1000 over 500, which gives us a concentration of 0.8 moles per decimeter cubed for the benzoic acid. Do exactly the same for sodium benzoate. So here we have the general expression, substituting in the values, and we get a final concentration of 0.1 mole per decimeter cubed with respect to sodium benzoate. So now what we need to do is we need to look at this equation, and we need to remember a few things we need to know about buffer solutions. The first thing we need to know is that benzoic acid, being a weak acid, we assume has no dissociation, so effectively HA is the same as 0.8 mole per decimeter cubed. Here we can assume this value is the HA value, even though some of it will have slightly dissociated. That is negligible. And the second thing we need to assume is that sodium benzoate dissociates completely. So in other words, it breaks up into sodium ions and benzoate ions, A minus here representing the benzoate ions. And because it dissociates completely, we can assume that the A minus ions, or the benzoate ions, are 0.1 mole per decimeter cubed. So we have, for this expression, we have all of these three values. We have the Ka, we have HA, and we have A minus. And what we now need to do is to put those values into the equation to get a value for the hydrogen ion concentration. So let's just do that. And here is our hydrogen ion concentration. And now pH is quite simply minus the log of this value. And let's quickly do that. And there we are. The answer to this question, the pH of the solution is 4.3. And the final section, which asks for pKa, is quite simply the minus log of the acid dissociation constant, which is 6.3 times 10 to the minus 5. So if we actually minus log that value, we get a pKa value of 4.2. And that answers all of sections B, C and D of question 2. Hope that's helpful. Thanks.